So good morning, everyone. My name is Shiun. My matrix number is 210922. I'm from the Department of Mechanical Engineering.
My name is Faiz Nasser. My matrix number is 120158, and I am from Mechanical Department too.
Hi, my name is Farra Alyssa binti Faizan. My matrix number is 212588. I'm from the same department as well.
Yes, and our professor is Dr. Ujila. So we are going to do our assignment video today. So our topic is applying matrix algebra to spring systems. So basically, we're using matrix algebra to solve the complicated questions to find the tension of the mechanical system of the springs. Okay, so what are the objectives, Faiz?
So our objective, we concluded that we have three objectives. The first of all is to apply engineering mathematics in real world situation. The second is to use matrices to represent and solve multiple linear equation and simultaneous equation. And the last one is to conclude the tension of spring by using matrices and its identities.
Yes, so that is our objective / learning outcomes. So I'll brief everyone about the vague questions first without including the value. So basically, we are trying to find a spring system's tension. So we have wall A here, we have wall B here. So in total, we have two masses. So this is weight 1, this is weight 2. So these two masses are connected to three springs, which is K1, K2, and K3. So we know that from the basic physics formula that we have F, the formula of springs equals to spring constant K times extension of the spring X. Okay, so basically we are changing the force here to tension. So it's going to become T equals to spring constant times the extension of the spring. Okay, so we have K1, K2, K3 here. We have natural length here. And we have the fixed wall distance, which is capital L. Okay, so we basically need to calculate the values of x1 and x2. So the first step is to represent them in a simultaneous equation form. So basically, we have two simultaneous equations. We can write tension 1 equals to tension 2. So the left-hand side of this weight equals to the right-hand side of this weight. Okay, since the spring is in equilibrium, so the three tensions should be of the same value. So the second one, we can basically write tension 2 equals to tension 3. Okay, so I think we can represent this simultaneous equation in matrix form. Just subbing out the x's, we will get this. And we can calculate the value of the x's, x1 and x2 using the second equation here. So let's move to Farah to introduce us to our real world question.
So I'm going to read the real questions. Springs with stiffness of K1 equals to 55 Newton meter, K2 equals to 45 Newton meter, K3 is equal to 20 Newton meter, and natural length of L1 0.2 meter, L2 0.2 meter, and L3 is equals to 0.4 meter are fastened to the walls at A and B with a distance AB is equals to L of 1 meter between point A and B. So calculate the X1 and X2 equilibrium values by using Hooke's law to calculate the tension, which stipulates the force is proportional to the object size.
Okay, Farah, thank you. So can you introduce us to how to solve the actual question? Because this is quite a long solution. We'll work together to solve it.
Okay, first of all, since the forces are in equilibrium, so all springs have the same tension, which means T1 is equals to T2 is equals to T3. So T1 is equals to T2. We convert the T1 and T2 to their respective equation that we got earlier and substitute all the values that were given by the questions. And then you have to solve the equation algebraically. And as the result, you will got an equation. So For T2 equals to T3, the method should be same as T1 and T2. And as the result, we got two simultaneous equations with two unknowns, which are x1 and x2.
Thank you, Farah, for your explanation. So right now I'm going to explain this question by using matrix forms. So first of all, we can go back to the previous equation and we can convert it into matrices. So you can see the under here. We need to convert it into the matrix form and we get this kind of equation. So we know that 100, -45, -45, 70, bracket x1 and x2 is equal to A. And then we can use the identity because inverse A times A is equal to identity. But right now we have a problem. How are we going to find the inverse A? So it is basically we need to use a kind of formula, which is 1 over AD minus BC bracket D negative B negative C and A. And then we just need to use the measurement and calculate it. We get 1 over 5,475 bracket 75, 45, 45, and 100.
Okay, thank you, Faiz and Farah. So until here, we basically get the inverse value of A1. So our job is to just sub the inverse value of A1 into this equation because we want to find the x1 and x2. Okay, so after subbing in the value of of A inverse, so we can get multiplying this with this first, we can get this. And we'll multiply the fractions into the actual answer. So our final answer after all the calculations, we will get x1 equals to 0.2370 and x2 equals to 0.5322. We are using 4 significant figures. So we have our x value and we think that calculating the tensions are just subbing the values in. So according to the question, because the system is in equilibrium, so that we are supposed to calculate the same tension values for all three of the springs. So the first tension after calculation, subbing in into this formula, we get 2.035 Newton. Okay, so the second tension, we'll get 2.034 Newton according to the formula here. So the formula is all at the front. So the third tension, we'll get K3 times L minus X2 minus L3, we'll get 2.034. Okay, so as you can see, we almost get the same tension. So in real life, it's supposed to be the same tension for all three springs as the springs are in equilibrium. Okay, so with this, we have completely solved the problem of the tensions just by using matrices formula to represent our simultaneous equations. Okay, so the question is finished. Let's move to our conclusion.
Okay, so the conclusion are we can see that engineering mathematics can be applied to real world situations and to solve complex engineering problems. As we can see from the previous questions, we use matrices to represent and solve the multiple linear equations and simultaneous equation. Next, we are able to calculate the tension of springs by using matrices and its identities.
Yes. So thank you, Farah and Faiz. So we have already solved the question and we have understood the using matrix algebra to solve simultaneous equations. So I think that's the end of our assignment video. So thank you, Farah and Faiz, and we'll end our discussion here. Bye.